Right, so lecture 9 will be the first of a series of lectures that I will be delivering on governing equations of fluid motion. The learning objectives of this lecture are application of physical laws or principles, general approaches. So I'll be talking of two fundamentally different approaches that can be used to apply physical laws in case of deriving the governing equations of fluid motion. So this will be very important for us, as we will be picking up one of these approaches and following it in all our subsequent development of governing equations. Okay. Next, we will in today's lecture we will follow this up with application of law of conservation of mass to obtain the continuity equation in differential form. So I believe you are already familiar with continuity equation and its differential form, but as you will see, in this case we will show you that the two approaches, that fundamental approaches that we will first introduce them to you, then we will show that both approaches, what kind of differences we get in the law of conservation of mass when we use them, and how the two are connected. Okay. So the governing equations of fluid motion, they can always be obtained by applying macroscopic well-known principles of physics or classical physics, you can say, to an individual fluid particle. Now I stress upon these words because an individual fluid particle is a material or physical entity. So all physical principles, classical physics, in classical physics, they are all valid for a system or a material entity, well-defined piece of matter. So an individual fluid particle, at least notionally from the continuum concept, is very well defined. Okay, so we can, this is the smallest physical entity, so we can apply all physical principles to it and get the governing equations of fluid motion in differential form. So this is what I call as the direct and very straightforward way of applying the physical laws. So as I have summarized below, there are two distinct ways. One way, which is on the left, that is, we can apply basic physical laws by considering a fluid particle. This is the most direct way, and this is the route that we will be following in this course. But of course, when you read the textbooks and you go into the literature, you find both of them are quite liberally followed. In fact, at the undergraduate level, many times we observe that books are following the infinitesimal control volume approach rather than this approach, and you will notice that in fact if a little observation is made regarding the first approach, that is the direct approach, in fact the results can be obtained very fast and with very little effort mathematically, but for some reason which is actually quite inexplicable from our viewpoint, the infinitesimal control volume approach is often followed in many texts. There are some very basic plus and minus associated with these two approaches. So we can look at the aspects of the two ways I have written on the left and the right. The direct approach of using a fluid particle and applying physical laws means that the working is, since a fluid particle is the smallest physical entity, laws can be directly applied, of course. Whereas, if you go to the other side, the first point is that a control volume is not a physical entity, and that we know that it's not a physical entity, it's just a volume in space, and hence laws cannot be applied directly. That's why you have been taught the Reynolds transport theorem, which is the the main bridge that connects the physical laws and the control volume, that acts as a bridge. Okay, so that means you require some extra principles in case of control volume approach, and so it is it is a more you can say a lengthier approach, which involves more ideas and concepts than the direct approach. Now the second point is that here there is some mathematical advantage also with the direct approach that we have using a fluid particle. The working is short and we get the result very quickly. This you will directly see when we use both approaches to derive the continuity equation. So here, as I mentioned earlier also, the Reynolds transport theorem has to be employed with a specific choice of the control volume. So in a nutshell, we have two approaches, the particle approach and the infinitesimal CV approach for deriving all physical laws for which are governing the fluid motions in differential form. So we will see now how we can proceed with the two approaches, and I take the case study of law of conservation of mass. Okay, the example of law of conservation of mass where I try to demonstrate the two approaches.